Recording. And good morning, Ian Coates here. I hope you guys are doing all right. Where did my meeting go? There it is. Very good. So, just checking the comments there. There are no comments. I hope everyone has made it okay. Apologies on the, I don't know what happened. Hello. Hi. If you have a question, let me know. If not, just mute your mic there, and we'll go on. But please interrupt me anytime. I'm okay with it. I'm okay with it. Today's lecture, there we're gonna show you guys PPE, hand washing techniques, some sterile techniques, modes of transmission, and today is interesting. I don't think I'm going to blow anyone's minds there today. I'm not in the habit of blowing up people's minds, by the way, but I hope that today's class will be all right. I don't think it'll be any issues. So if you guys are good, I'm good, and I'll start screen sharing, and away we go. Perfect. Now, and okay. There we go. PowerPoint is up. I'll start sharing in 2 shakes. There's my share screen. All right. So we are recording and we have everything up and go. I hope you guys are doing all right. I can't see your comments. So if you post your comments, I'll get them there at the end of class. And if you don't feel like waiting until the end of class, then just interrupt me. Okay, here we go. PPE, Personal Protective Equipment Program Goal. We all know, if you don't know, you're going to know there today. PPE, okay, Personal Protective Equipment, okay, and for all sorts of jobs, there's PPE. If you were doing construction, hard hat, right? Safety gloves, these kinds of things. Work boots. It's just a part of doing any job. And it's just the whole idea, we go into the lab, we work, we do our day's work, and then we get out of the lab and we go home to our families. So there's nothing, to me anyway, there's nothing more important than family. All right. So you guys are all taking this course there to better yourself, better your families, better your family name, however it goes, whatever your reason is, I don't care. As long as you have a reason. That's the only thing I care about, is that you have a passion for learning and this course and things you do. So we just do everything safe. We get in and we get out. Definition. Okay, this is by OSHA. This is America here, the Occupational Safety and Health Administration. Okay, specialized clothing or equipment worn by an employee for protection against infectious materials. Okay, we are doing this there for more of a microbiology tinge, but you know what I mean. It's all just a matter of protecting yourself, health and safety wise. Okay, OSHA. Regulations, recommendations. OSHA issues workplace health and safety regulations regarding PPE. Okay, employers must provide these for the employees. Ensure that PPE is disposed of in a way that is clean and orderly. Okay, whether it needs to be tossed out into the garbage, maybe it's biohazard, needs to be burned and disposed of this way. Maybe it just needs to be tossed in the trash. Okay, these kinds of things. And you'll see there that where we're going, we're kind of... Last week was just more of an intro, right? How you doing? My name's Ian. What's your name? This is the course here, the objectives, the syllabus. Here we're starting to branch out a bit into the course itself. And today it's more about why. And we'll get into that. Okay. The CDC, the Center for Disease Control, which I'm sure you guys have heard of many times over the past 18 months or so there, issues recommendations for when and what PPE should be used on a particular job site or in preparation or defense against a specific pathogen or infection. And you know what I mean? Like, we're not doing rocket science here. You know what I mean? This is what today's lecture is. So it is what it is. All right. And types of personal protective equipment, gloves. Okay. What do gloves do? They protect your hands. Okay. Gowns, aprons, they protect the skin or clothing, aka a lab coat, right? And you ever wonder why a lab coat tend to be white? So if anything gets spilled on it, it's easy to see. Okay. Masks, respirators. Okay, we're all about masks. That's where we're at. Respirators, they protect the respiratory tract from airborne infections. Okay, and you'll see there that some of them there they have cartridges on them, and all these kinds of things. Goggles, face shields, and hair color, or hair color, hair covers. Perfect. Um, and we just go into these goggles there to protect the eyes, gloves there to protect the hands. If there's any comments, I don't think this is too crazy stuff. We're just going to kind of fly through this. There are 60 slides, but honestly, I can't see us being here more than an hour and a bit. Gowns, okay. And you've got all the stuff here, right? There's your face shield and all these kinds of things. Factors influencing PPE selection. Exposure, like a 5-second exposure as opposed to a 1-hour exposure. Different kinds of PPE you'll need. Okay. Touch, splash, or sprays, or large volumes of blood. These, and it all depends. If you're working in a little clinic there, okay, you're gonna have PPE that's specialized there for your clinic. If you're working in a clinic, not a clinic, let's call it an emergency center of some kind, there's going to be different PPE involved because you're dealing with different cases. Okay. Even you look at like a little clinic there, like you've all seen the show Dr. Pimple Popper. And my daughter, she's 8, and we've, you know what I mean. I'm a science nerd, and I love it. And you try and get the kids into science and math, and all these kinds of things. And yeah, Dr. Pimple Popper is a great show for us, anyway. And you'll see there that it's, a health setting, but the PPE is different than it would be in another setting like this. And watch the show; it's really good. Kind of gross, which sometimes can be cool. Welcome to Health and Medicine. So what we got here? Types of exposure anticipated, and fit is a big thing. PPE is no good if it doesn't fit. It's gotta fit. And people wearing respirators and masks, these kinds of things, like a respirator is supposed to go tight on the skin. All right, kind of create a seal. It doesn't work as well if you have a beard or these kinds of things. Durability and appropriateness, it's all things there that have to be factored in. And you want to follow things there by your governmental ministry and your employer. Selecting gloves, okay. The glove material, vinyl, latex, nitrile, and they all have different things. Some get worn, some start to come apart in the presence of alcohol. Okay? And hopefully they don't come apart in the presence of, water-based, these kinds of things. But you have to look at the material strengths and its weaknesses, and maybe these gloves here are good for water-based activities. These gloves over here are good for oil-based or alcohol-based activities. It all just depends, and you'll have to, I think in here we talk about an MSDS sheet, okay, material safety data sheets. We'll get in there, okay. Sterile, non-sterile uses. Single or reusable, okay, these kinds of things. Do's and don'ts of using gloves, okay. I apologize if this seems very rudimentary, but this is all part of the course, and we'll show you there later on how to, you have a plastic glove here, and you got your rubber gloves on, right? And you just performed your open heart surgery, all right? and you're done. The patient has made it. Now, how do I take off these gloves? How do you do it? We'll show you guys there. And as kind of rudimentary as this PowerPoint is, it's actually some good information there. We mentioned there last week that we like to work from clean to dirty. And that's how, and when we get into the more specifics, I think that's probably our last lecture where we actually go into like the schematics of a building and reusing things, cleaning things, sterilizing things, and putting them back into use, right? And things go from clean to dirty. Limit the opportunities for touch contamination because these things tend to be quite dirty, all right? So we want to limit the amount of touch. Keep them out of the way. Keep them untouched until they're needed. Okay? We've all heard this a billion times. Don't touch your face. I don't know how many times we touch our face in a daytime. I've heard silly numbers like somewhere 1,000 to 3,000 times a day that we actually touch our face. You know what I mean? Look, I just did it 3 times. And if you touch your face with contaminated gloves, you better go get some new ones. Okay? And touching environmental surfaces, like when I'm in the lab there, especially there the past 2 months there when I'm in the cell biology lab, we, you take your 70% ethanol, you got your gloves on, you spray down your entire desk before and after your lab bench there. But when it comes into the bio lab there, we tend to, there's really not the opportunity there for recycling, and we tend to throw things out. So what to discard, what to reuse. You never wash or reuse disposable gloves. You just get them out of there. Okay. Sorry, I can't see if there's anything more. There is. And again, if your gloves become infected, change them. Get another pair. Face protection. Like where we're at now is you walk into the lab and you either have to have your goggles on or you have to have a face shield. And the face shield isn't the nicest thing, but in some jobs it's mandatory. Masks, they protect the nose and the mouth. Like that's just the whole thing there with the COVID vaccine. How we have to stop this virus from getting in. Okay, so not the vaccine. I apologize. There, the COVID virus. Okay, and the skin stops all things from getting in. All right, but then you've got the nose, the ears, the mouth. That are potential ports of entry, which we'll get into there today. We have the whole thing on transmission. Okay, this lecture here is kind of 2 parts. The first part there is PPE. Second part there is modes of transmission. Okay, and how to stop. Okay, these modes of transmission. Okay, the face shield should cover the forehead, extend below the chin, and even wrap around the side of the face. All right. And what do they mean by wrap around? You don't want to wrap plastic around your face. That's not what it's saying. It's sorry, I'm just gonna move that up there. It's just got a bit of a curve to it. Okay, you just don't want a flat piece of face shield because then things can get in, right? Perfect. Respiratory protection. Okay, purpose there to protect the inhalation of infectious things. And I like this, infectious aerosols, okay? And a lot of bugs, and I use that word, I'm not talking, invertebrates here. A lot of these microscopic bugs, that's how they get in. Somebody sneezes 10 meters away, and the aerosol trickles in, lands on your face, you touch your face, you rub this stuff all over your nose, and then therefore now you got it, okay? And there's lots of these here, powered air purifying respirator. Here we're getting a little high tech, but this is where we're at. Okay. Key points to remember. Wear this before even getting in the room with a patient or somebody else. Okay. Because if you're putting your PP on in the presence of somebody else, and I know, you know what I mean, you're getting ready for work, your shift, you've got 5 other people in the change room that are putting on PPE at the same time. you know what I mean? You do what you can do. But generally, you know, from a medical point of view, if you're coming into contact with somebody who's infectious or infected, or you don't even know, protect yourself. Because that's what this is all about. Protecting yourself so that you are okay to do your job, do it safely, so that you can protect others in a manner that is good enough to get you home back to your family safe enough. Isn't that what life's all about? Yes'm. All right. Please use carefully. Don't spread contamination. Okay, and that's just the whole thing. Is like I think the worst thing for me was, you know, you have the mask on and goggles and these kinds of things, and you have an itch. You know, I mean, here, and you know, and it's if you gotta scratch it, scratch it, but then you gotta go and decontaminate again. All right, because these things here tend to be dirty. All right, and it's not you, it's not me, it's just our hands, our first point of contact with interacting with the outside world. Okay, and that's how it works. Okay, so that's it. Just protect yourself, be aware, and have your PPE on before you interact with other people, or you're going to do your thing. Don't put it on as you're doing it. Okay. How to put on a gown. Okay, and these are the dreaded hospital gowns that open at the back. All right, but then you see here, you can also have these gowns here that have, you see they're what's the word? They have, I want to say wristband, but they're not wristbands. They're wrist cuffs. All right, and you'll see there that they're to limit infection. Anything coming up the sleeves of the, you know, if you look here, bugs can get in through here. Okay. You select the appropriate size and type. Size being to fit you. Okay, and not just standing, but for moving and being able to do your job. Because if doing your job means you have to kneel down or bend over, well, then your suit has to, or your gown has to allow it to do it. So it's all about size and type. There are different types, different strengths for different levels of infection. And we've all seen the movies there. You know, you can go on and find some virus movie on Netflix and all that, right? And you'll see them there. They're got their hazmat suits on and all this kind of your own independent air system. Okay, so some of them there. Opens in the back, secures the neck and the waist. If the gown's too small, use two. Yeah, that's great advice. Yeah. One ties in the front and one ties in the back. I guess that would work. I don't know how you'd get the back one on, but perfect. I like it. How to don a mask here. Place over the nose, mouth, and chin. Do I really need to teach you guys how to put a mask on? I'm just going to skip this, and yeah, I think you guys are good with that. How to wear a particular respirator. Now, maybe, you know what I mean, whatever place of employment there that you know, you get a job, and they'll show you how to do all this. They'll probably pay you 3-4 hours to go and take an online course. You select a fit tested respirator. Again, it's gotta fit, and if it doesn't, the whole thing is useless. Place over the nose, mouth, and chin. So it's just everything there is secure, and secure on the head with the elastic. The nose bridge there fits over. It has to be adjustable, because when you move, things can move. All right, so there has to be a bit of adjust in there that you can, you know, maybe you put it on in the morning and you find out there by break time it's too tight. Loosen it up a little bit. Okay. Inhale, exhale. There's your fit check. Okay, and you can hear and feel leaks around your face. Okay, and just, you know what I mean, your head is hollow, and you can get this resonance, and you can feel the vibration, right? And through that method there, you can check for leaks and these kinds of things. Okay. What do we got here? There we go. Wearing eye and face protection there. You position the goggles over the eyes and secure to the head using earpieces or a headband. Okay? And, you know, wearing some goggles there, I don't know, you just be careful there because you tend to, maybe you might get a headache there. You know, it's pressing out some blood vessels there behind the ear and all that. Just be careful. Everyone's different. Okay? You position the face shield over the face and secure on the brow. Okay? If any of you guys have been in the lab in the recent time, you guys will know all about this. And again, adjust to fit. How's this stuff? Pretty crazy, eh? Woo! Woo! I told you. This lecture's pretty far out. Yeah. Donning gloves there. The also you put your gloves on there, insert the hands into the glove, and you extend the glove over the isolation area. So you're putting them on, right? You put one on first, and then your other one on, okay? And we've done this as well. There's really no crazy technique. There's a bit of powder in the gloves there that allows the hands to slide in relatively easy. Not sometimes. It all depends on the humidity in the air and humidity on your hands and all that. And depending upon the lab session there, you may have to, the gloves, your hands will get sweaty and this and that. And you'll have to change them and all that kind of stuff. But keep the gloves there. Again, like we all just want to touch our face. And yeah, I know you can't see it in the video, but I got my hand on my chin like this. So if I keep my hand on my chin for like 5 minutes, how many touches does that, 1,000, right? But you just want to avoid touching things that are not part of your job duty. And you know what I mean? You got an itch, you scratch here. Now you have to think, is that glove contaminated? And it's all just you guys make your own choices, and but you just want to limit surface contact. Okay? And if you need to, get a new pair of gloves. Okay. Contaminated. Oh, I left my coffee downstairs. Rats. Maybe I'll text my wife downstairs and tell her to ask her if she'll bring my coffee. But contaminated versus clean. And you'll remember there that I think it was last week there that we talked about the whole idea of I think our definition of clean has been contaminated by advertising companies, and just the whole idea of cleaning your whole house with Pine Sol and dragging a hot dog through the house. You wouldn't need it because now this hot dog has all these dangerous chemicals on it. So you have to think, well, Pine Sol says that my house is clean after I use its product in my house. Well, actually, all you've done is you've just put chemicals everywhere. And depending upon the severity of the outbreak, or if you're just cleaning your house, in theory, you really don't need any harsh chemicals. In my house, we use vinegar and water to mop the floors. And I know you're thinking, oh, vinegar, man, what are you thinking? But non-toxic. And yeah, it stinks for a couple minutes, but just open the windows up. Even in the wintertime, you know what I mean? Open the windows up for a couple minutes, and the vinegar, it's pretty good. And you're not using all these harsh chemicals. That's the whole thing. What is contaminated and what is clean? And you see, here we're talking on a societal scale, but for the purpose of the PowerPoints there, we're talking on a medical grade. So the contaminated outside front areas of PPE that have or are likely to have been in contact with a body site, materials, or environmental surfaces where the infectious organisms may reside. So basically, that's what we're talking about. Contaminated. If something is contaminated, it doesn't even matter if it really is contaminated or it's suspected of being contaminated. It's the same thing. And that's how we deal with things, because there is no chance for error when we're talking about contamination. If something is perceived to be contaminated or if something is suspected of being contaminated, please treat it as such. Okay? And like a surgeon there with a scalpel, and if it's suspected of being contaminated, gonzo. You know what I mean? We're not going to, I'm not going to use this to open up somebody for surgery and the possibility of it being contaminated. Of course, right? Okay. So clean inside, outside, back, ties on the head and back, areas of PPE that are not likely to have been in contact with infectious organisms. So yeah, like if you got your goggles and you got the band in the back, and it's saying here the outside back, the ties on the head. Even I wouldn't even say that the ties on the back of your mask are clean now, because maybe you washed your hair, maybe you didn't wash your hair. Even if you wash your hair, there's still bugs in here anyway. They get right on there back in an hour or two. So and contaminated, clean, again, you make your own judgments there, and err on the side of caution. Okay? Never leave anything to chance, especially when you're talking with human health. Okay? This one here, if you don't know it already, know it now. Okay? In a medical setting here, or an environmental setting, or a lab setting, this is how we take off gloves. Like, you got your 2 gloves on, right? And you've just performed your open heart surgery, or you've done your testing. Okay? How do you get these gloves off? Well, your hands underneath are in theory clean, right? It's the gloves that are dirty. So the gloves go down to about here. All right. So you take, both your gloves are still on. Take your glove right here. Grab the other glove. Not underneath, not at the edge of the glove, but a little bit up. So there's still a little bit of rubber back here. You pull this guy up, and just before your fingertips come out of this glove, you can start pulling on the other glove. And there are some videos there at the halfway through that we're not going to do, but you guys can do. Okay, and you guys have the PowerPoints there, so you guys can have a look at that. There's some good sterile techniques there. Nothing too crazy though. Okay, I don't think it's anything there that you guys haven't seen before. Okay, yeah, really nothing that we haven't seen before outside of a CSI TV show. Okay, good. And you'll see there, okay, and you see how you've got a clean thing, and this is this way here. There's 2 ways, multiple ways you could do this here, and this and you'll see here that they've taken off the one glove. So you've grabbed it, you've taken it completely off, and now you have a clean hand, and you go in under the glove. Pull it up, and you see how you've got one glove inside the other, which is what you want, right? Because then it just goes right into the bin. Okay. Goggles, face shield. Like, again, this isn't rocket science. You teaching you how to put goggles on here. Grab your ear or head piece with ungloved hands, lift away from the face, place in designated receptacle for reprocessing or disposal. Okay, so taking these guys off here, you know what I mean? It is what it is. And like I bought on Amazon a couple of these face shields there last year, and I think they were like $2 a piece, and they're great. They have a foam pad on here. They have your curved shield coming all the way down here, and it's curved. Okay, and you got the little band with a little clasp, and take it on. And I've been using it there for the past year and a half. Okay, and even one of them there, I've actually cut right here. So you have your face shield coming down, you have your mask here, rock and roll. Because if you tend to have your mask and your shield, the whole thing gets foggy and you can't see. And that's not good if you can't see. Removing your gown. Great stuff. First thing you do is you unfasten the tie. True. You can't take your gown off if you don't untie it first. Peel away from the neck and shoulder first. Okay? And you kind of take it, how do you say it? You're kind of taking off your skin from the inside. So you get inside the gown, take it off, so that the outside is away from you. Sorry, I'm using my hands here. I'm trying to, yeah, you get in here, you take it off, so that the outside is away from you, the inside is closest to you, the inside is sterile in theory, and wrap it up into a ball so that the former inside of the gown is now on the outside. Throw it in the bin. Okay? Crazy stuff, I know. And look at that. We're halfway through. Woo! Removing your mask, untie the bottom, then the top. Okay? And depending upon your mask there, like, these cloth ones there, we keep. Okay? Wash them in the washer and reuse them. But a lot of the masks there are disposable. Okay? Removing a respirator. Okay, these aren't the nicest things to wear because they're tight. You know what I mean? They actually, when you take them off, you can actually see a crease. And a million years ago, when I was your age, I worked at the Honda plant in Alliston, making Honda Civics there, and in the paint department. And oh yeah, that's your job there. 8 hours a day is wearing that thing and sanding paints and cars and all these kinds of things. And you see how this is like the proper way. You've got the lower band actually goes on kind of the top of the head, and the higher band goes on the on your occipital lobe here. Okay, and but that's how it goes there. Hand hygiene. I don't know how many times you wash your hands a day, but in a hospital setting, environmental setting, I don't know. You need to wash your hands, keep them all clean, because again, these guys here tend to get infected or contaminated, not infected, but contaminated quite easily. Look, I just touched the tabletop. This hand is contaminated now. That's all it takes. All right. And perform hand hygiene immediately after removing PPE. Of course, wash your hands after coming out of the gloves, right? If hands become visibly contaminated during PPE removal, wash hands before continuing to remove the PPE. Wash hands with soap and water. Okay? Or you can just use an alcohol-based hand rub there. I think it's any type of alcohol rub or gel. Even just I think the percentage is 70% minimum. That's what kills COVID. Anything less than 70 is less than effective. Okay. What we do is we'll buy the 99% ethanol there from Walmart. You can get a big jug of it there for a couple bucks, and then you just water it down. And anyone wants to, if you guys have some chemistry, you can figure out the molarity and do some dilutions and get that 99% alcohol down to a 70%. Save yourself some money. If you need some help on that, let me know. Okay, so, and they say to be washing your hands for anywhere from, I think it's 25 seconds minimum. And, you sing a song, these kinds of things, whatever, but it should be about 20 seconds, 25 seconds, somewhere in there. Standard precautions there. We've got the gloves, the gowns, the mask, the face shields there. So the gloves when you use there to touch blood, and touching blood doesn't mean you can actually see it. Like, for a CSI murder investigation there, we've all seen it on TV, that you walk into a room and, oh, this room looks very good. Well, if you turn off the lights and turn off the black light, or turn on the black light there, you can see, they put a special solution on there, and you can see, the fluorescent properties there of the blood when chemicals applied to it, and you can see all the blood splatter. So you don't even know that it's there. All right? So it's the whole thing. Suspected contamination is just as good as actually being contaminated. Okay, so use when you suspect that there's blood, body fluid, secretions, excretions, contaminated items for touching mucous membranes. Okay, these kinds of things. Gowns there we use during procedural and patient care activities. Okay, when contacting clothes, exposed skin. Okay, um, because your gloves are there because you're going to interact with instruments or the patient in some way. The gown is there to protect your body and to protect them from you. You got to think PPE is twofold, right? Not only are you, yeah. For me, the most important thing is protect me. For you, the most important thing is protect yourself. But ultimately, in doing so, me wearing this protects you. You wearing that protects me. That's how it all goes, right? Mask and goggles, face shield. There using patient care activities like to generate splashes or sprays of blood, or even Dr. Pimple Popper there when she's opening a cyst of some kind or something like that. Sometimes there'll be a squirt. Hey, this is the body. The body can be very disgusting. So that's what it is, and PPE there is to protect you from disgustingness and infection. So I apologize if that was kind of rudimentary. I think you guys are, you know what I mean, like what, you think from a testing point of view, and not too difficult from a testing point of view. Okay, so have a look at those. Here we've got some video links. Okay, you please have a watch of these. There could be a couple questions there from these on the tests. You know what I mean? There's from your CDC, Center for Disease Control, how to safely put on personal protective equipment, how to wear and remove an N95 mask. Okay. N95 mask fit. You guys can watch all these. The hand hygiene. Okay. Have a watch of these. And yeah, have some fun. They're not too bad. How are we doing there? Oh, there was one. If stuff or so good. Okay. No, you know what? And maybe I'm taking this kind of for granted because you know what I mean. This is kind of my biz, right? And I deal with PPE all the time. And maybe we've all been dealing with PPE for the past 18 months, right? And wearing our masks and washing our hands and not touching our face and 2 meter rule, contact, and what I mean, all these things, right? So the PPE is kind of big business now. Could you imagine the person who already had a mask company and then the pandemic hit? Boy, man, they're probably retired already, millionaires. And but this is good to go over again. It's good to refresh because when you do, when you do get a job in this and you are in the field, the PP and hospital situations regarding COVID and PPE and procedural issues, these will never go away. Okay, these COVID issues in a healthcare setting will always be there, and I think masks will be around for a while. Okay, so just take care of yourself. Have a look at these videos. They're not too taxing, but have a look at them. All right. Was there? Well, it's good. Cheers, Monica. I'm glad you can take something away from this, and I think it's great. Okay. And if you guys have any questions, let me know. But that's your PPE in a nutshell. Like we didn't really go into hair nets. You know what I mean? And but hair nets are another factor. Even foot protectors. You know what I mean? Kind of what I call them foot gloves, and you put those on over. And but when you get into a lab there, when I was the lead there at this mushroom biotech farm, and yeah, we made shiitake, maitake mushrooms, and it's quite incredible how they make those. But yeah, you tend to have a pair of indoor shoes that never comes out. You buy them brand new, your employer buys them brand new, they're in the box, and the box is opened up inside the lab so that these shoes are as clean as can be. Okay, so All right. But we do all this PPE, and why? We're going to go back to why we do all this PPE. Because we want to stop transmitting bugs from one person to another. That's what it all is. And what makes diseases, what makes pathogens, so evil is they can't move on their own. So they are genetically engineered over billions of years of evolution. They want you to pick them up. They want you to scoop them up and stick them in your nose. Okay, they're programmed. They're designed to be nose stuffers, and that's the problem. And that they're just evil. They're designed to do that. They are waiting for you to do that, and us just living our lives, touching things, this and that. We are doing their thing. So we want to stop this transmission of the pathogens. So today we're going to talk about chain and modes of transmission. This is the second half here. This one here is more, I think this one will do you guys more. There are, just to be on the safe side, when you're dealing with biology and microbiology, anything to do biology related, you're going to learn partially a new language. Animals, the plants, fungi, all these, what I mean, they have a common name, but they also have a scientific name. And with scientific names, you're going to have scientific definitions. You're going to have new things here. So, like right there, pathogen is an organism that causes disease. As simple as that. Okay. If you guys ever, I don't know your backgrounds. If I assume there you guys have at least some type of scientific, and I know you guys do by talking to you guys. But if you ever get a chance after this course, wherever, take a course on it. It tends to be in more health related programs, like nursing and these kinds of things. But there's a course, every college has it. It's called pathophysiology. And the there's a fly. You're gonna get it. Pathophysiology. It really goes into the diabolical, the devious nature, the evil nature of these pathogens and how they are preordained, predestined, genetically engineered to get you. So, awesome course is pathophysiology. And if you ever get a chance, take one. Yeah, it'll be the most fun you ever had. Everyone learns about anatomy and physiology of the body, right? This is my left arm, carotid artery, your left atrium, you know what I mean? All these kinds of things there, your hepatic portal vein and all, you learn the body. But learn how diseases have adapted to get certain parts of your body just evil. And you can't really know how things work unless you know the good side, anatomy, physiology, and the pathophysiology, the evil side. And it's fun. Knowledge is power, right? The human body is naturally full of microbes, and we talked about this there last week. There are a lot of good bugs, and we need them, or we ain't going to make it if we don't have these good bugs. However, these microbes can cause a problem in your immune system if weakened, or if they manage to enter a normally sterile part of your body. See, this is one of the problems, and I railed about doctors last week giving antibiotics out like candy, and I don't like it. And you see, you have all these natural bugs in your colon. You need these bugs in order to digest beans and these kinds of things, and that's why you make sounds after, because these bugs are doing their job. And through this process, we are able to extract vitamins and things there that we normally couldn't get. Right? So we need them. There's a symbiotic relationship there. And let's say we do get sick. We have a viral infection. It's a virus, not a bacteria. And the doctor gives you antibiotics. And what these antibiotics do is they wipe out all the bacteria in your body. So all those good bacteria that were lining your colon doing a job are now gone. which now, and you see, if all the good bugs were there before, there's going to be bad bugs here or there, but if the good bugs have all the spaces, there's no space for a bad bug to get in there, and the good bugs will overpower them and kick that one out. But if there ain't any good bugs in there anymore because your doctor just gave you antibiotics because you have a viral infection, and now those bad bugs can get in there and get a foothold right into your colon, right? So you got to think. Use this, because I find there that, yeah, I'm just going to leave that. Use this. This is your greatest gift, okay? And make choices based on your needs, okay? All a pathogen needs to do is thrive and survive in a host. Hey, you know what I mean? And there's lots of pathogens out there, like, yeah, you know what I mean? COVID, you've got HIV, you've got ringworm. Oh, you've got these malevolent, evil bugs out there, you know? And but we'll get into a couple of them there today. Once the pathogen sets itself up in a host body, it manages to avoid the body's immune responses and uses the body's resources to replicate. Evil. Can't replicate on its own. So it commandeers, like the HIV virus there, we talked about it there last week. You know, it just commandeers a T cell, which are your defense cells, and uses your defense cells as an incubator to make more virus. Horrible, evil. There are different types of pathogens, but we're just going to focus on 4: virus, bacterial. There's fungi, parasites there. There's with the onset of COVID. I've been reading reports there in the subcontinent there in India that the Delta variant is, rampaging. It's just going through, and what's happening now? It's people's lungs are becoming compromised, right? And the mold fungus that can be found in people's lungs. There's one called black mold. Ooh, nasty. Nasty stuff. And people are not so much dying from COVID, they're dying from this black mold, which is now it's preying upon these compromised lungs of these people there that have COVID. So again, fungi, mushrooms are great to eat, love them, but there are some bad fungi out there, bad molds, okay? And then you've got parasites there. Okay, we'll get into some of these. This, to me, is fun stuff. I like this stuff here. Pathogeneticity. This is where I need my coffee. And I got to text my wife and ask her if she'll bring my coffee up. Pathogenicity. Okay, I'm texting my wife to bring my coffee. And I'm reading this at the same time. Refers to the ability of an organism to cause disease. So, there are, in different environments, bugs have a greater or lesser ability to infect you. Okay, and we'll get into these kinds of things. You even look at here. Before I continue, I'm just gonna ask, can you please bring coffee? Thank you. Okay, so it all depends on the environment itself and the susceptibility. Are you in a situation where you have a weakened immune system? Well, then you would become more susceptible. Maybe you have moved from one environment to another environment, which changes your susceptibility. Okay, and maybe the bugs have more of an ability to infect you and cause trouble in this environment as opposed to another. Okay, the minimal infection dose, the number of organisms required to cause an infection. Okay, the minimum infectious dose of SARS-CoV-2 this virus there that caused the COVID-19. We're getting there. We're still learning about we don't even know about how, we do know there that it doesn't hit children as hard as it hits adults. Interesting. Why is that? But recently now in the Delta wave, this is the fourth wave, I think I read on CNN there this past week that 29% of the new COVID cases in the States are children. So there's what's happening now. And these things there that when the bug has an ability to transmit and contaminate someone else, these things, they have a very short replication time, like bacteria replicate in 20 minutes. And the more replications, the more chance you have for variants. And therefore now we have the Delta variant, Lambda variant, and you know what I mean? How many variants are there going to be? So this is how these goes here. Mode of transmission. The way a bug travels from place to place. So the mode of transmission, how a microorganism travels. Because they don't walk, how do they get to where they need to be? Okay. Oh, good. The coffee's coming. Oh, thank you. The HAI, healthcare associated infections. And this is going to be a strange word, nosocomial. Okay. And this means healthcare associated infections. And you think, healthcare associated infections. What? Healthcare shouldn't be associated with any infections, right? Healthcare is there to stop infections. We like to think so. And this is a big problem, is people go into the hospitals to get treatment for one thing and they end up getting something else. Okay? And you have to think that you walk into a hospital, and I don't think I've ever walked into a hospital where... Sorry, there's a fly buzzing around. I don't think I've ever walked into a hospital and loved the smell. There's that putrid chemical smell that you expect with a hospital, because they ain't using vinegar in a hospital. They're using the hard stuff. And so, because a hospital is a house where sick people come to get better. Well, you get enough sick people together, it's going to be a house of disease. So this is actually a big problem, nosocomial here. Diseases originating in a hospital setting. Okay? And they're acquired during the process of receiving health care for something else. And you just look at these numbers here, and you know what I mean? These are all just suspected, right? You know, because we don't know. Not everybody, you know, someone will get a disease there from a hospital and go home and they'll survive, but maybe they suffered for a week and went to work. We don't know. But you talk about the lost productivity of work. In 2010, there are 8,000 deaths in Canada annual. Well, this is what they say. I would say that there was more. 220,000 infections. I would say that there's more. And they estimate the cost here, and this was 11, 12 years ago here, $130 million. Okay, and medical device reprocessing department of the hospital plays a major role in preventing this, because you know what I mean. If you got a scalpel there that was used for a certain procedure, you reuse that scalpel, not the blade, but you use the scalpel handle, and that's why these contamination or decontamination processes are so important, because we know that there is a potential for catastrophe. Something gets back out there onto the floor, and yeah. Okay, so that's HAI. Oh, sorry, I wanted to say this as well. I put these down here. Here, like they say, the top leading ones causing death there: cancer, heart rate, heart disease, stroke. But I did some digging there, and I found there that urinary tract infections. That's a big one. And men compared to women get more urinary tract infections because their urethra is shorter, okay, than the man's there with the penis. So that's a big problem, because any infection in there, and now you're 3 inches away there from vagina, the uterus, these kinds of things, and then the uterus there. Now you're just right underneath the main organs, okay, and blood supply, and we just do not want to get infection in that area, right? Pneumonia, that's a big one there, viral infection, or sorry, not viral, but that's what we've got there. Pneumonia is a big one. Infections there from surgical sites, okay. Bacterial, gastrointestinal for sure, okay. Eating food, even from the hospital food. You got to think everything there has got to be sterile, crazy. And you ever wonder why they have a little tray over your food? To protect it from bugs in the air. Skin infections, big time. Um, and skin infections can happen anytime. There 2 weeks ago, we just went for a walk and came back, and about 2 hours later, I had a rash on my arm. So I don't know. Don't think I came into contact with anything, but it's called contact dermatitis, where we really don't know what had happened, but the skin is irritated. Okay. Chain of transmission. Certain conditions must be met in order for a microbe or infectious disease to be spread from person to person. So let's go over that again. Certain conditions must be met. Okay? That virus over there in that tree isn't just going to sprout wings and jump on over. Okay? All right? It has to. How is it going to get here? Certain things have to be met. And this process is called the chain of infection. Okay, can only occur when all 6 links in the chains are intact. I'll show you there. You guys can see the slide there that's next. Okay, and we'll go through these. Breaking this chain at any of the links will stop the spread of infection. So the focus here is all about breaking the chain. And you'll see here that this is your chain there. So you have a look here. You can start anywhere. Susceptible host. Okay. And you get infected somehow, some way, okay? Now, the reservoir there, this thing is growing, it's breeding inside of you, it's commandeered a couple of your cells, and these cells now are not working for you, they're working for the virus, they're making more virus, or, these kinds of things. And then it gets out, somehow, you sneeze, however, okay? How mode of transmission, how is it, what is its thing, how is it looking at you? Because these bacteria, they're looking at you. How am I going to get to you, right? Well, in order for that bacteria or virus or whatever, you've got to have a portal of entry. And we have a number of portals of entries. Here's one, here's one, here's one. We have some others as well, okay? And through the portal of entry, however it moved, and we're back into susceptible host again, okay? And what we're talking about here is cutting any of these anywhere. And like a susceptible host, if you're vaccinated, double vaccinated, you have now cut the chain right here, okay? So you can have you know what I mean? If you're fully vaccinated, still wear your mask, still wear all these, because we don't know enough about COVID there to do anything yet. Seriously, we have no idea. So, and that's what the next year, every year they're doing massive testing, and they're just trying to gather some group data to see if there's any trends that are going on here. And we know the effects there on the elderly. We're just learning the trends there now. People under 30 need to be careful. And so nobody is immortal. Please protect yourself. But if you're fully vaccinated, doesn't matter. Get a COVID up your nose, and in theory there, the virus won't be able to replicate, and it stops there. If you stop any of these at any given point in time, we should be able to stop transmission. Disease organisms or agents, these are the pathogens that cause communicable diseases from community. And you'll notice there that when COVID was just kind of starting up. There was, the people were initially interested in the chain of transmission of coming into a country. Whether it's by car or by plane through Pearson Airport, all these kinds of things, right? But there's that kind of transmission. But then once the pathogen, the COVID virus, was in the community, now we're talking about communicable diseases, people passing it on, in their daily lives. It's a different kind of transmission. Okay? And that's why we had lockdown, because we had to stop that mode of transmission, right? So we got bacteria, virus, fungi, parasites. The type of organism informs you of the type of disinfectants, antiseptics, antimicrobials to use. Is it aerobic or anaerobic? Aerobic means oxygen, breathing. Anaerobic means not in the presence of oxygen. So aerobic has to do with oxygen. Anaerobic, no oxygen. And you think there that the muscle use there, it's kind of the difference between a 100-meter sprinter and a 400-meter sprinter. You have enough oxygen and sugars in your muscle right now so that, oh my gosh, if there's a bear right here, I can run. I didn't even have breakfast. I don't even have my coffee yet. How can I run? Because your body has storage already. Okay? You're familiar with your sympathetic, parasympathetic nervous systems there. If a bear is going to eat you right there, you will, depending upon your physical capabilities, you should be able to run a kilometer as fast as you can to get away from that bear right now. Your adrenaline will start kicking in, these kinds of things, right? So the aerobic, that's a 100-meter sprinter. At the end of a 100-meter sprint, the person really, oh yeah, they're breathing hard, all right, but they haven't exhausted fully all of the sugars and oxygen already in their muscles. I guess they kind of have, but you know what I mean. A 100-meter sprinter is using the oxygen and sugars that are already existing in your muscles there. Blood, you have hemoglobin. In your muscles there, you have myoglobin, kind of oxygen storage tanks. Okay. The aerobic, that's aerobic, and anaerobic means without oxygen. And so you look at a 400-meter sprinter, after about 100 meters, they don't have any more oxygen or sugars left in their muscles, so then all of a sudden now they got to start breathing, kicking in, and getting more oxygen in there, and they're making energy there without. So it's different, all right? So aerobic, oxygen, anaerobic, no oxygen, or in the presence without. And there are some bugs that don't use oxygen. Have a look at these there. Virulence factors. These are toxins, toxin production and particular effects that affect the course of the infection. Okay. What is its target host tissues? These are all things there that have to be answered. Okay. And like you look at HIV, they're going after one type of cell. Dastardly. Okay. The only cell there that can stop HIV. Breaking the chain, infectious agents there, antibiotics, okay, used to treat the infection, okay. Antibiotics are great when needed. They are destructive when used unnecessarily, okay. Clean, disinfect, sterilize medical devices and equipment to remove and kill the infectious agents and eliminate the potential pathogens. So, right there, using sterile techniques, disinfection, sterilization, antibiotics, these kinds of things, that's breaking the chain. The reservoir of an infectious agent is the habitat in which the agent grows, replicates, multiplies. Okay, this is the reservoir where it's kind of lying dormant and just festering, growing, multiplying, and then at some point in time, it's coming. Okay, and people, animals, wild animals, sure. Food can be an agent of replication. A reservoir here, plants, waterborne. You know what I mean? All these kinds of things. bugs can live, and you enter. What I read there happens not often, but you've heard of there's a brain-eating amoeba. All right, this is a parasite, and I think I read somewhere that somebody went swimming in a watering hole in Florida, just a pond, and yeah, man, they got this brain-eating amoeba, and yeah, man, they were really sick. Okay, so just be careful of where you are, and it's all just a matter of using this. Know your environment, and how do you know your environment? Through knowledge. How do you know something? You take a course like this. The reservoir there, breaking the chain, housekeeping, okay, repurposing your medical devices in a proper way, okay, because you want to strip these bugs of their reservoir. You don't want to give them a place to breed and multiply. You don't, okay. Uh, Throwing alcohol there on your workstation before and after. When I was working in a microbial lab there, our lab bench was right here. Sorry, you can't see my hands, but your lab bench is right here. Okay, spray it all down. Okay, it's completely disinfected, and I was working in front of what's called a HEPA filter, HEPA, HEPA filter. And so the air in the room is getting sucked through the HEPA filter, and yeah, it was probably about 3 feet by 4 feet wide. And so I had basically decontaminated air blowing on me. So there's no bacteria, no viruses, no fungi, nothing blowing on me, nothing blowing on my workstation. So that after I cleaned it all with alcohol, in theory, you'll see I'll use that word a lot, in theory. In theory, everything in front of here on the workbench should be sterile. Okay. Engineering controls, we can control the heat, the ventilation. UV lights is another one there. Humidity control. Bugs like a certain humidity. If you do not provide them that humidity, they will not grow. RO water. I like to say Culligan water. I'm not advertising for Culligan water at all, but you know those big blue water jugs that you can buy there for I don't know what they're going for. Probably $10 a jug. You can get them at Walmart or whatever. And there's a red cap one. There's red. There's blue. There's all these. The red cap one is what we call RO, and basically this is just what we say reverse osmosis distilled water, deionized water. Okay, it's been put through a filter. It's been cleaned. It's just agua, just water. Okay, there's no minerals, no nothing in it. In theory, it's clean. Okay, and wastewater disposal. If you've never had a chance to go through a wastewater plant, I recommend doing so because it's quite interesting how, like, all the water that comes from everyone's toilets, you got to think about that, all the water that comes through people's sinks, these kinds of things, and how do they deal with this water? How do they clean it up? Because all the water has got to go back into the environment. And they actually use microorganisms. They use bugs. You know, the water trickles over, and they have all these different layers and different bugs. We got different bugs here that take this thing out. You got different bugs here that take this out. And in theory, at the end of the whole process there, the water goes back into the bay, and it's clean as a whistle. Interesting stuff. Yeah. Have some fun. What do we got here? You'll have a look there at cardboard. Generally, we tend not to use this. The corrugated shipping boxes, cardboard there, not permitted because things can get. It's a great place. You can see right here. Great place for bugs to live. Okay. And you got to think boxes are stored in dark spaces, right? And dark, humidity, warm, humidity, a little bit of moisture, that's all bugs need, really. Okay. Yeah, good enough. RO water, reverse osmosis there, removes contaminants, microorganisms from unfiltered water or feed water. We've talked about this there. The water flows from the more concentrated side. And you have to think, osmosis, particles aren't moving, water is moving. So you have water, you have a membrane, and then you have water over here. Well, if this water here coming out of your tap, we'll call that dirty. It's not. We drink it, it's fine. But there's water, calcium, magnesium, bicarbonates. There might be some bugs in here, probably chlorine as well. So there's water and stuff. And over here, there's just water. So the water with stuff here, we call this more concentrated. Because if I have 1 liter of this water and 1 liter of this water, well, this is pure. This one here is not. So things will move, will gravitate towards the clean side there. So water flows from the more concentrated side with the contaminants to the side there that has less. So that's how we make reverse osmosis water. Easy peasy. And you have a look here. Is there a question? I hear something. If you have a question, please ask. Please. And I just put this picture on here. We'll go into this kind of stuff there later. But you'll see here, this is like a basic RO system. And colleges have these. Like Seneca has I can't say for sure the exact same system, but it has a system that is very similar to this there for all of its labs. Okay? Because you go into the labs, you have your taps, hot and cold water like you do in your house, but then you'll also have an RO, a deionized water tap. Okay, that we use there. Like you can wash your beakers and all that kind of stuff with soap and normal water, but then after it's been rinsed, you give it one final rinse there with the RO water to get all the stuff there that's off of it. Okay, like calcium, magnesium, these ions. But here's your dirty water here, comes in. Like this is the multi-stage filtration. Okay, and you'll use charcoal, carbon base, these kinds of things. There's a triple filter system, comes through a 4-stage. Okay, and it can either go into your clean drinking water, okay, like an RO tap there in a biology lab, or it can go into a storage tank there, these kinds of things. So there is such a huge industry behind this medical device reprocessing. Billions of dollars being spent not on saving people, on this whole underlying issue of getting things ready to go to save people. And good stuff. And you just look here, like these are medical grade there. We've got tweezers here, we've got scissors here, and you know what I mean, these scissors ain't cheap. These are not your dollar store scissors. These are scissors there that they would use in a hospital, and they're stainless steel. These things are not designed to rust, right? But if you're using normal water there with all the ions and these kinds of things, there is a potential there for things to get, minerals and things to get caught in here. Like your coffee maker, every probably 2 to 3 months, what I'll do is I'll fill up the coffee maker with vinegar. Well, half and half, vinegar and water. And you don't have any coffee grinds in there, so the water and the vinegar goes through and takes out all the what's the word I'm looking for? Calcified minerals, all these minerals there that have congregated on the inside, and sometimes your coffee maker can get stuck and it doesn't kick up any water. So this is the whole thing. If you're using RO water, you won't get issues like these. Okay. We're still on up here. Remember this one right here? Okay. And we're looking at the reservoir, and this is the whole idea of us being a reservoir. Oh yeah. Bugs love to get into us because we're warm, we're juicy, and we eat all these good things, and why wouldn't a bug want to get into us? We're good. Sure. Diseases that are transmitted from person to person without intermediaries. So here we're talking about like sexually transmitted diseases, measles, mumps, streptococcal infections. There's your pneumonia, and any respiratory pathogens. Human reservoirs may or not show the effects of illness. This is the big thing there that we are dealing with the COVID, eh? Who's got it? Who doesn't have it? Well, as it turns out, if you are exhibiting symptoms, you know what I mean? And, that's a sign that you have it. But there's a lot of people that are exhibiting no symptoms or mild symptoms. Okay? And, maybe you just 3 or 4 months ago you had a mild flu. You had some sneezes. You didn't feel good there for, an evening. You went to bed early and you woke up fine. Okay? And maybe you're sneezing 2 or 3 times a day and you actually have it. This is the trouble. Do you have it? Don't you have it? You just have to assume that everybody has it. Okay? And because the asymptomatic ones are the ones that are walking around, I don't have it, I feel great. But really, they're passing on this pathogen there to everybody else. So, asymptomatic or passive or healthy carriers are those who never experience symptoms. Okay? So, asymptomatic. And you see, these are the words there. And you'll see there in the second half of this PowerPoint, there are some really, really, really good words. Okay? And I love matching on, definitions, these kinds of things, because you really can't walk until you've crawled. And this is kind of the crawling thing. We're working on our vocabulary, our microbiology vocab. Asymptomatic, no symptoms. Okay. Incubatory carriers are those who can transmit the agent during the incubation period. Okay. So, yep, you can move these things while they're still in an incubation phase. Convalescence carriers are those who have recovered from their illness but remain capable of transmitting to others. Convalescent carriers. Chronic carriers are those who continue to harbor a pathogen such as hepatitis B or Salmonella typhi. They cause the agent there for typhoid fever months or even years after. So a chronic carrier. Somebody who has hepatitis B, they are still able years after to transmit this. Hepatitis C, okay, these kinds of things. Oops, sorry. Carriers commonly transmit disease because they do not realize they are infected. Of course, nobody wants to infect somebody else, but from the greatest intentions can come the greatest of harm. Okay, and consequently, these people here, they take no special precautions to prevent the transmission, and that's a big thing there that we're finding there with the COVID transmission is people getting together in large groups. Okay, and I guess this was more last year when there wasn't a vaccine available, and just the whole idea, like they limited their for the longest time it was only families could get together, and then you could have extended families get together. I think up to groups of 10, and then it went to 20, and you know what I mean. It's just the whole thing is we just don't know, and just the horrible things there you hear about. Last year you hear about people getting together there, more so in the States, people getting together for marriages, weddings, these kinds of things. And after the marriage, there was a COVID outbreak and a couple members of their family passed away. It's sad. It really is. And that's the thing with disease. It doesn't care about anything, who you are, background, language you speak. It's just looking for a home. All right, so just please always protect yourself. Symptomatic persons who are aware of their illness, on the other hand, may be less likely to transmit infection. They'll probably stay at home. They'd be more safeguarded. They will probably use PPE more and probably follow the 2-meter rule. Okay? Maybe they're just too sick to get out of bed to transmit it. Okay? But these guys here are probably taking more precautions there to reduce transmission. Okay? So you got asymptomatic, symptomatic. Good words in here: chronic carrier, convalescent carriers, incubator carriers, asymptomatic. You know what I mean? These are all good. Love them. Love them. Portal of exit. So you have the bug. The bug is looking to get out. Okay? And our portals of entry tend to be our portals of exit. Okay? Portal of exit is the path by which a pathogen leaves its host. Portal of exit usually corresponds to the site where the pathogen is localized. Respiratory tract, coughing and sneezing. All right? Like, what do they say there? A sneeze is traveling at, is it 90 miles an hour? It's just flying out. And you can go on YouTube and you can see these slow-mo of those high-definition cameras, a slow-mo of what a sneeze and how far it actually travels. Like, ew, gross. Cover your arm. That's one of the first things I taught my kids there. Don't cover your sneeze like this. Well, if you have to, do it. Sorry, I don't know if you guys heard that or not. But cover your sneeze at all costs. Okay? If you cover your sneeze with your hands, please wash your hands. Tend to cover your sneeze there with your the cup of your elbow. Gastrointestinal tract there. Okay, vomiting, bowel movements. You look at the parasitic worms. Like for dogs, and actually people get them too. You take deworming medicine, right? Which is it's a poison. You give your dog a worm pill. You should be giving your children, we should be taking these worm pills at least once a year. Please follow your doctor. I'm not a physician, but you consult your physician there. We should all be taking worm pills. Don't take the same worm pills as you would give your dog. Don't you dare. You didn't hear it from me. Don't do it. But the whole idea there that dogs, they get these worms, they're sniffing around the park and maybe they, and a worm gets in their mouth. Or an egg gets in their mouth, these kinds of things, dogs, feces, these kinds of things, and worm gets in, it's in the intestinal tract, and it lives a happy life, and it makes eggs. The eggs go out into the feces, or a dog will lick himself, clean itself, and the eggs go back into the mouth again, and you'll see there, it's a cyclical event. That's how these things, and it's worked for millions of years. So, and that's how good these worms are. The genitals there, again, we get into their urethra size. The size of the urethra there in females tends to be smaller, so therefore now the susceptibility for getting infection is much greater. Okay, skin, you get a cut, open wound, there we go. Mucous membranes there, the eyes, the mouth, okay. The membranes there, some of these pathogens can just flow right through them just like water, okay. And blood, bleeding, these kinds of things. So just know your portals of exit, okay. Breaking the chain there, the portal of exit, hand hygiene, washing your hands, PPE, proper disposal of waste and contaminated linens. Oh yeah, this stuff here, dirty clothes in a hospital setting, oof, get it washed ASAP or burn it. This stuff is just a breeding ground. Like, I don't know if you ever walk into a hospital and you see a dirty clothes bin. I'm not a germaphobe. I'm aware, but get that away from me. So, yeah. Breaking the chain here. Controlling your excretions there, covering your cough, covering your sneeze, wound care, okay, not letting things get out of control with a wound, and clean it, hydrogen peroxide, some ethanol on the wound, stitch it up, sterile bandages, away you go. Dedicated elevator for soiled pickup. Oh yeah, get that stuff out of here, get it back to the decontamination center. And obviously avoiding public areas. Okay, we don't want to be taking these dirty clothes out through a surgical environment. Okay. Modes of transmission. Okay, we're on the tail end here now. I don't know. I'll check the comments. If you guys have any comments here, let me know. But yeah, modes of transmission. An infectious agent may be transmitted from a natural reservoir to a host in different ways. Direct contact. Okay, this occurs through skin to skin, kissing, sexual interactions. Okay, direct contact also refers to contacts with soil or vegetation. Okay, infectious mononucleosis. Okay, aka also called mono. We call this there the kissing disease, gonorrhea, these kinds of things. Even this one here is a bad one, hookworm. Okay, contaminated soil. You've got ringworm, which is contaminated water. And these things, if left untreated, can just be absolutely horrible. Horrible. And there's so many parts of the world that are they just deal with these things on a daily basis, and it's really sad. And but yeah, these hookworm and these ringworms, just horrible. Droplet spread as opposed to direct contact. So here it's skin to skin touching. Droplet spread refers to the spray in the air, kind of like what would we say, aerosol. Yeah, there it is right there, aerosol. Okay, and like these viruses and bacteria, they can't really exist out on their own. They can, but they need water. Like these are all, they're just water bugs, as are we. And if you take away their water, but not even taking away their water kills some of these, because these bacteria, they can revert to what's called a spore, and let's call it an egg. And these spores can live they're not alive, they're just there. And when the environment is right for them, they will germinate and they'll get your bugs back. And that's one of the big problems there with climate change, especially here in the north, Canada and Russia. We have a lot of unused tundra that's frozen, and there's frozen bugs in there from 10, 15, 100,000 years ago that are going to be coming out of the ground soon. So we've got to protect ourselves. So again, direct contact, droplet spread, kind of aerosol. Indirect transmission there refers to the transfer of an infectious agent from a reservoir to a host by suspended air particles right here. Airborne transmission. Okay, this is what we got here. And you guys can have a read of this. And yeah, but even kicking dust up, these kinds of things, you're just bringing dust into the air. Dust isn't the problem. It's the things that are living on the dust that are floating through the air that get into your nose and get by the nose hairs in your nose and get in and infect you. Okay? Indirect transmission here, like take for example vehicles. Like I just, these kinds of things. Somebody touches something and then they're long gone. They touched this door handle there 4 hours ago, and then you touched the same door handle. Okay, may indirectly transmit an infectious agent: food, water, biological products, blood. Fomites, inanimate objects such as a handkerchief, bedding, or surgical scalpels. Interesting word there. I like that word. A vehicle may passively carry a pathogen. A taxi. You don't want to say it, but toilets in a mall. What can you say? They're all over the place, and it's just a matter of protecting yourself. And I don't, my goal, isn't to scare anybody. And I don't want to freak people out, and I don't want people to be shut-ins and stay at home, and I'm never going to go outside again, because please don't, and but the whole thing is you have to be aware, and look at wherever you're going, always be aware of the infectious nature of things that you cannot see. Because they're all there. There's bacteria everywhere. All right? So protect yourself. Alternatively, the vehicle may provide an environment in which the agent grows, multiplies, and produces toxins. Y'all have heard of botulism. Maybe you haven't heard of botulism. This one here, take notice. If you ever buy a can of food, soup, beans, spaghetti sauce, whatever it is, a can of food. And you just want to be careful before you buy it. Look at your can. You know, a can is a cylinder, right? And any type of, what's the word I'm looking for? Any type of dents or any misshapenness to the can could be even a bloating. Okay? And, you know, you look at it, be cautious. And then when you use your can opener, let's say you take that home and it looked fine, you know, it's a normal looking can of soup. And you open the can up, and if the can, when you put the can opener in, and if it goes, just like when you open a bottle of pop, Coca-Cola or Pepsi or whatever, and it goes, because that's all the gas escaping, right? If your can of that you just opened did that, throw it out now. And I mean now. Now. Because that's botulism. And that's a bug that got in there in this environment. And you have to think that this bug is in this can of beans, and there's no other bugs in this can of beans other than this botulism. So this botulism is now kind of growing artificially in this environment that's good for it with no other bugs to eat it. So this thing here is full of botulism. And botulism will kill you. And quite quickly. So just a letter there. Okay. So in this case here, look, your vehicle could be a car, could be a bus, could be a handrail, could be a can of tomato soup. Be careful. Indirect transmission here. Here we're talking vectors. This should kind of make a little bit more meaning making here. Mosquitoes, fleas, ticks. We talked about these there. I think there were mites there, ticks that actually caused the Black Plague. We talked about that there last week. Okay, where these guys, the disease doesn't harm these guys, but these guys are carriers. So I think it was fleas for the Black Plague. Mechanical transmissions are flies carrying Shigella on the appendages, and fleas carry Yersinia pestis, the causative agent of the plague. All right. And biological transmissions, okay, the causative agent of malaria or guinea worm disease undergoes maturation in the intermediate host before it can be transmitted to humans. So these guys here, like for malaria, it grows and develops within the bug bites you, gets in that way. Okay. Hand hygiene is about breaking this chain. And you'll see there that hand hygiene, I think it's in all of them there. These guys here, your hands, I love my hands. And you should love your hands too. But know that they need to be washed all the time. Okay? Love your hands. Of course you should. And your feet. Don't forget about your feet. Isolation of patients. And this is the isolation. It kind of it's a bad word, isolating. You know, you're kind of in jail. But it needs to happen. Because there will come a time, hopefully, you know, that you will not be infectious anymore. You will not be able to pass this disease on to somebody else. Okay? Engineering control, of course. That's where we're going to get, you know, we've even got the mRNA virus. It's all in there. Environmental cleaning, for sure. PPE, disinfect, sterilize the equipment. And in a hospital setting, in a workplace setting, there where you're dealing with high volume of people, lots of traffic, you better use your industrial strength chemicals. In a home environment where you spend the majority of your time, I use vinegar and these kinds of things. And my wife wasn't initially on board, but then, you know, a little bit of research, she did that, and the vinegar is good. Portal of entry here, this refers to the manner in which a pathogen enters a susceptible host. Okay? It must provide access to tissues in which the pathogens can multiply. Because if a pathogen gets in and it doesn't have the cells that it needs to replicate, it ain't going to make it. What do we got here? There, the infectious agents, they use the same portal to enter a new host that they would use to exit. And you got here many pathogens that cause gastroenteritis follow what's called so-called a fecal oral route. These are the worms there that affect your dog, my dog anyway. Okay, because they exit the source through the feces, and then the dog licks himself, and then they come right back again. Okay, it's a circle effect. Other portal of entries include the skin, hookworm, mucous membranes, syphilis, blood, Hep B, and HIV. These kinds of things, right? Okay. And again, look at that. Here's all your breaking the chain, and all of this kind of makes kind of sense. Hand hygiene, PPE, aseptic techniques. Okay, don't touch your face. Proper wound care, medical device reprocessing department, disposal of your equipment. Okay, first aid, you got to have it all over the place. Okay, operating your medical device reprocessing equipment. Okay, and this one here, when I looked at it, this could be one of the most important. There's no point in doing any of all of this if at the end of it all your equipment is clean, but you don't keep it clean. And we'll get into this more and towards the end of the course there, the whole idea of what happens there with those sheets and all those linens. They become clean. How do you store them so that they stay clean, so that you can ship them out next Monday to Mount Sinai Hospital when you need them? Okay. What do we got? Now, a susceptible host. And you see here, we got babes, we got kids, we've got older people here. Okay. But what is a susceptible host? And that's the whole thing. Susceptibility depends on many different things like genetic, communal factors, constitutional things, specific immunities. Like the whole theory, nature versus nurture. What makes us who we are? Okay, we were all born at some point in time, and we're just we are what we are. Our mums and dads gave us our DNA, and there we are. We're born sitting on the bed, and I'm looking up at myself. There you go. What makes us us? By the time you're 12 years old, you are a certain person. You have likes, you have dislikes. Oh, I like vanilla ice cream and not chocolate. Why? I don't know. It's just me. What makes you who you are also makes up who you are and your susceptibility to pathogens. Now, is it a bit of your DNA? Absolutely. There are genetic factors that stop us from getting diseases and actually enable us to get diseases. We're all different that way, right? But then there are also environmental factors, okay? And population, sociological factors that can increase or decrease a person's susceptibility to a certain disease. If you look at malaria, malaria, we know, is a very bad, debilitating disease, and it affects the normal RBCs. But there are certain areas over in Africa where their RBCs, red blood cells, are not the same, and they have what's called sickle cell. And it's where your RBCs, they actually kind of look like crescent moons. And the ability for these sickle cell RBCs, the ability for them to, absorb oxygen and transmit oxygen to the rest of the body is limited. There's an issue there. But it's an environmental protective factor that has come over time that protects people against malaria. And it's if this is your first bio disease type of course, we're just touching the iceberg. And there are many medical marvels that are out there, and we'll try and touch on a couple of them when we get there. But it's just amazing. Like sickle cell, quote unquote, is not good. But in the case of malaria, it is good. And it protects people from malaria. Malaria isn't really prevalent in this part of the world, but in more temperate climates, it is. And it can, people will live longer with this condition as opposed if they didn't have it. Interesting. So genetic makeup is important. Okay, it can increase or decrease susceptibility. Antibodies, you between the time of being born and 12 years old, you did things. You interacted with nature on a different level than somebody else did, so therefore you've been exposed to certain things. And through exposure, you can gain immunity. Welcome to a vaccine, right? That's what a vaccine is. They're injecting a little bit of non-lethal disease into you so that your body has an immune response. Oh my goodness, we're infected. But really there's nothing there to infect, but the body creates an immunity based on that fake infection. Okay? You know what I mean? There's lots of things going on here. Factors that may increase susceptibility to infection by disrupting host defenses, including malnutrition. That's a big one, right? Alcoholism, lifestyle choices, socioeconomical factors, okay, education, all these kinds of things will increase or decrease susceptibility, okay? On a scale that I'm not willing to go into because there's 15 different PhDs wrapped up in this very one slide, okay? Susceptible host could be very young, very old, right? That's an easy one, okay? Very young, they really don't have, for the first couple months until a baby develops a bit of immunity, all of the baby bottles, everything has got to be sterilized because baby really doesn't have a really good immune system as of yet. The elderly, their immune system is waning. Okay, it's down the downside, so you can see there that they could be immunocompromised. Somebody there with organ transplants. If you've got someone else's liver in you, okay, you have to take drugs, what we call immunosuppressants, because your body is sensing there that, hey, this isn't our liver. Where's our liver? This is not our liver. So if you don't take these immunosuppressant drugs, your body will actually go after that liver that you need, right? Chronic health issues, cancer, these kinds of things, recent surgery, organ transplant there, chemotherapy, there's lots of these kinds of things, okay? All right. This one here I just put in, this is something there that you might fill out. You can't even really read it, but I just wanted you guys a staff immunization and surveillance policy information sheet. So in any type of a health-related environment there, they'll make you fill out this. They want to know what you're susceptible of. You got to have all your shots. You got to have all these kinds of things, right? And with the whole COVID vaccination, there's a passport that's going to get rolled out. I think it's on Tuesday. You've got to be fully vaccinated or you won't be able to do this or this or this or this or this. And I'm not here to, you agree with it or you don't agree with it. That's all right. It is what it is, right? And so that's what's going to go on there. That's just a sheet there that they will make you fill out and all that kind of stuff. And you know what I mean? I put this there at the end there, achieve the best respirator fit. You know what I mean? And you guys can have a read at this. I think we've done PPE kind of way too much. And I think you guys are highly skilled on this already. Breaking the chain of infection there, the role of the MDRD. We've got to stop. We've got to snip this chain somewhere. Because as long as you snip the chain somewhere, that chain is broken. But the moment there that we take our foot off the gas, the moment there that we're not really paying too much attention there, all it takes is for one of these chains there to get into us and we can get sick. And depending upon the organism, we could die. So protect yourself. Each disease, infectious organism presents unique problems. Knowledge of a specific disease can break the chain at its weakest link. Okay, routine practice, additional precautions, aseptic techniques, and sterilization procedures prevent the spread of infectious microorganisms among everybody. And that's residents, people you work with, people you live with, people, maybe you're in a condo and there's 500 other people in the condo. You know, these kinds of things. You guys are all sharing shared air in the hallways, in the elevators, these kinds of things. That's what it's all about. And again, I'm not saying these things to scare you. Okay? Please don't be. It's real, and these are livable, survivable techniques that you should be practicing every day. And if you choose to go into this field, you will be practicing them. And you know what? The way things are looking there with COVID, I don't think this thing's going away anytime soon anyway. So you just keep on trucking and getting her going. And last slide. Woohoo! Cleaning your hands. And I'll say that 1,000 times before this course is over, okay? Staying up to date on your vaccines, okay? Covering cough, sneezes. Stay at home when you're sick. Follow the rules for standard and contact isolation. Using PPE the right way, because using PPE the wrong way isn't going to get you anywhere. So that is today's class, and I hope you guys are doing well. Do you guys have any questions for me? I'm going to stop sharing. I do have some. One question. Have you had colleagues who had difficulty with goggles if they have prescription glasses? If so, yeah. Script glasses, that's a tough one. Because like in my labs there, like when you're doing intro bio or intro chem, they make you wear those big wonky, they look like bug eyes. They're big wonky plastic. They got a green back here, and they're really uncomfortable. And when you take them off, you've got these rings on here, and but people who wear prescription glasses, you got to wear glasses, right? You can't see. Just the whole thing is, I have people who have prescription glasses, but you got to have the tops on them. And I'm sorry, I'm not pointing at my eyebrows. I'm kind of simulating the top of the glasses, because you're pouring liquid solutions using all these kinds of things. Liquid can fly, and you've got to have, there's a top protector on the top and also sides as well. All right, and a lot of glasses, they just have the lens right here, but there's nothing protecting you anywhere and around here. So that's one of the big issues. And if someone's just going to wear glasses in the lab, I don't do it personally. I be a stickler and I say, I'm sorry, you've got to put the big wonky ones over top of your prescription glasses. And you know what I mean? If they steam up, they fog up, they're irritating you, you can take as many trips to the front of the class, take them off, to have a drink of water, and then put them back on again. It's just one of the things. And I'm sure that you can actually get prescription prescription goggle lens kind of a thing. But yeah, good question. I hope you guys are doing all right. Do you guys have any more questions for me? No? Then get out of here and enjoy your day. What are you still doing here? It's a beautiful day outside. I'll post week 3 there next week, sometime probably Tuesday or so. Probably Tuesday. And there's nothing going on there next week. The week after there, we'll have quiz 1, and I'll let you guys know all about that there next week. But other than that, I hope you guys are doing all right. Things are quiet, and we're just kind of starting things, but I don't think today will take you down too bad. But other than that, you guys have a great day, and we'll see you guys there next week. Thank you. Thank you, Carly. Thank you, Neela. Thank you, Carolina. I hope you guys are doing great. And thanks, Eva. Thanks, guys. Thanks, Anna. Thanks, Ellen. You too, Monica. Thanks, Jonathan. Thanks, Sandra. Susie. Lemuel. Good. Thank you, Francis and Josian. I'm just trying to get to know your names. Sandra, Mary, gotcha. Yeah, where is my coffee, by the way? I'm going to have to talk to my wife. She was supposed to bring me a coffee. That's right. Okay, thanks, guys. Have a good week. Be safe, okay? And if you have any issues, email me, all right? Something doesn't seem right, email me. We'll square it right up. Thanks, Dara. Thanks, Maida. Bye, guys. I'll post this there, too. Oh, and I'll post this... give me an hour. I'm still trying to figure out how to post it to the Seneca College website and not to YouTube. But I'll send an announcement out there later today, and it'll be posted somewhere so y'all can watch the video. Okay? Bye, guys.